This video is brought to you by Academy of Higher Learning. Hello and welcome to today's physics video on kinematic motion. In this video I will be going over the following: position, distance, and displacement. So let's start off with position. Based on Google definition, a position is a place where something or someone is located. And a position is a location vector, and it is in reference to the origin. So basically, the way position is taken is that the tail of the vector is on the origin and the head is where something is located. So it'll be something like this. So this is the origin, O, and the head will be at the location point, say P. So this so the position vector would be OP. So let's start with an example. So find the position of the following. So what we first have to do is we have to make a coordinate system. I've already started it and said that this is origin and everything left of the origin is negative and everything right of the origin is positive. But let's put a direction to it by saying that anything left you can either say is it's either you can put an L for left or you can say west, but just going to put left since we have two directions. And anything right is I'm going to say right, or you can say east. So find the position of the following. So the position of the mall would be, it is minus 10 of the origin. So you can either write minus 10 in the answer, or you can write 10, but you have to put left, or you can just say L in the brackets. B, the school is plus 10, so it'll be just either 10 or 10 right. And lastly, home, it's minus 20, so you can write down minus 20 or 20, and that is left, or L, but I'll just write it down. And lastly, racetrack, which is 20, you can either write down 20, or you can say 20 right, or you can even say minus 20 left, because it's in the other direction, but this is like pointless. So next is distance. Distance is a scalar and a physical quantity. It is a measurement of intervals between 2 points. So a general formula would be something like this: d for distance, absolute value, the second position minus the first position, absolute value. So, and whereas displacement is a vector and it's a change in position. So it goes something like this: delta D equals the final position minus the initial position. So the way to memorize it is basically distance is how much ground has been covered by the object, whereas displacement is basically the change in position. So here's an example. Say we have the origin here, and here's your home, and here's your school. So this is minus 20, and this is plus 20 meters, say for instance. Now you start from the origin and you go back and forth like 10 times. So the back and forth, that leads you go to school, then you go back home, then back to the origin. The distance you have covered is 20 plus 40, which is 60, then 20 again, that's 80. But the displacement is 0 because you started where you ended. So that's pretty much the difference. So here's a similar example: a racetrack. Find the distance between distance and displacement. So we have a racetrack, you start from here, and you have only 2 points, A and C, that you can travel to. So say you stop at point A. Okay, before we start doing that, for displacement you have to make a coordinate system, so let's do that, and that will be something like this. So let's go with north, south, east, and west. So up is north, down is south, east, and west, and let's make the start point the origin. So change color, blue, and say this is the origin. So pretty much we won't be using south in this at all. So let's start with the first question. You stop at point A. The point A is 20 meters north. So therefore, the distance that you covered is 20 meters, and the displacement with the vector sign is also 20 meters, but you have to give a direction to it, so it's north. You stop at C, so you go plus 20, so the distance would be 20 plus 20 to the left and 20 down. So the total distance you covered is 60. However, the change in position would be, remember, you have to take the final position, which is minus 20 west. So it'll be minus 20. So let's just say that this is negative, this is positive, negative, positive. So it's minus 20 plus 0. So, minus 0. Therefore, your final position is minus 20, which is, if you put it into direction notation, it will be 20 west, because going up and down cancels each other out. Last is, say you took 5 laps of the track. So the distance would be, one lap is 20 plus 20 plus 20 plus 20, which is 80 meters. Since you took 5 laps, so it'll be 80 times 5, and that will give you 400 meters. However, the displacement, pretty much the final and the initial position are the same. You started where you ended, therefore the displacement is 0 meters. So